Assalamu alaikum. Now, in the previous lecture, we were studying about chemical reaction and equation. We have studied about what is a chemical reaction, what is a chemical equation, what was chemical change, what was physical change. Any chemical change is denoted by a reaction, which is known as a chemical reaction. Now, then we studied about what are the steps in writing a chemical reaction, then how to balance a chemical reaction. Now today there is a new topic which is known as various types of chemical reaction. Okay? In this first type is combination reaction. Combination is the word coming from combine. Combine is to add. So over here you can see the basic denotation is A plus B giving you C, where A and B is the reactant and C is the product. A very simple example of this is hydrogen gas. Hydrogen gas and oxygen gas coming together to form water, which is a liquid. To form a water which is a liquid. So over here you can see that A plus B is giving you one compound which is C. So there are two reactants and one product. So now the thing is that you need to balance this. Hydrogen is 2 on the reactant side, 2 on the product side. Oxygen is 2 over here, but you have only 1. So you will add 2 over here. When you add 2, the hydrogen becomes 4. So you add 2. Now this is a balanced chemical reaction, which is of a type combination reaction, where 2 reactant combine to give you 1 product. So this is a combination reaction. Decomposition reaction. What do you mean by decomposition reaction? Decompose is to separate. Decompose is to separate. So over here you will have one reactant which will decompose to give 2 product. One reactant to give 2 product. In the earlier one, 2 reactant to give 1 product. So you can tell that combination reaction ka vice versa is decomposition reaction. 2 giving you 1 is combination and 1 giving you 2 is decomposition. A basic example, calcium carbonate on heating will give you calcium oxide plus carbon dioxide. Now you need to balance this also. So this is already balanced as calcium is 1 over here, 1 over here, O is 3 over here, O is 1 plus 2, 3 over here, and carbon is 1 over here, carbon is 1 over here. This denotation, you remember last lecture I told, the denotation arrow facing upward shows that this is a gas. This is a gas. Okay? So combination reaction, decomposition reaction. The third one is displacement reaction. What do you mean by displace? Displacement means changing its position. Zinc reacts with copper sulfate. Now over here, this copper will be getting displaced. Copper will be getting displaced, and instead of copper, zinc will come over here. So 2 reactant, out of which one is solid and one is aqueous, in which the aqueous solution, the metal changes and the new metal is added. That reaction is known as displacement reaction. Displacement means changing its place. Displacement means changing its place. So copper is changing its place with zinc. So this is a displacement reaction denotation. You can see over here A plus BC. This BC will get interchanged with A. B will come in place of A and A will come in place of B. So this A will combine with C to form AC and B will be separated. So B is getting displaced. Therefore the reaction is displacement reaction. Same way, this over here only one is getting displaced. So this is a single displacement reaction. The next type is double displacement reaction, where you have 2 reactants giving you 2 product. Where you have 2 reactants giving you 2 product, in which AB plus CD gives you AD plus CB. Now any chemical reaction, what happens? There is a formation of ions and these ions break. So A gets positive charge, B gets negative, C gets positive and D gets negative. A being positive combines with D negative and C positive combines with B. So there is a double displacement. A is getting displaced, A is getting displaced with C and D is getting displaced with B. Therefore this is double displacement reaction. silver nitrate plus NaCl, sodium chloride. Now you see this Ag being positive will combine with this negative, negative, positive, negative, positive. This positive will combine A. This is A over here, B, C and D. This A will combine with D. So this C is getting displaced with A and B is getting displaced with D. Therefore, it is a double displacement reaction. So these are the four types. Fifth type is endothermic reaction and exothermic reaction. Endothermic reaction is a reaction where heat is absorbed. Where heat is absorbed. For example, melting of ice. Ice is melting to water. It will absorb heat. So it is endothermic reaction. Exothermic reaction where heat is given out. Any acid you take, concentrated acid, and you add water, you see fumes coming out, and you will hear some whoosh, you will hear some that voice. That voice is because of the heat. So exothermic reaction is a reaction in which heat is given out. So these are the basic types of various types of chemical reaction: combination, decomposition, displacement, double displacement. Fifth one is endothermic, and sixth one is exothermic. Exothermic example, when there is an explosion of bomb, any nuclear bomb or any atomic bomb explosion, it gives out large amount of heat. So that is also an exothermic reaction. Now the next topic is factors affecting the rate of reaction. The first thing is nature of reactant. Nature of reactant means depending upon the nature, whether it is very reactive or less reactive, the rate of reaction depends. For example, over here you have hydrochloric acid reacting with aluminium and zinc. Out of this, the reactant is same, and there are two different metals, aluminium, zinc. But hydrochloric acid will react faster with aluminium than with zinc. So nature of reactant depends the factor nature of reactant. As the nature of reactant changes, the rate of reaction also changes. Size particle of reactant. Here you can see I have drawn same metal solid zinc. The size particle is big. Over here it is size particle is small. It is powder form. So in which case, this is case A, this is case B. In which case the reaction will take faster? It is this case. Because as the size particle decreases, the surface area increases, and where surface area increases, the reaction takes faster. So in order to create a reaction faster, you need to minute the particles of the reactant. You need to smaller the size. You need to create the size smaller so that the reaction takes faster. Concentration of reactant. Concentrated acids react faster than dilute acids. Dilute acid. For example, if you have two acid, one is 50% concentrated and one is 95% concentrated. What will happen? This 95% concentrated acid will react faster. Temperature also plays a very important factor in which affects the rate of reaction. As the temperature increases, the rate of reaction also increases. For example, reaction taking at 10 degrees Celsius and reaction taking place at 50 degrees Celsius. Which reaction will occur faster? Naturally, the reaction which is taking place at 50 degrees Celsius. As you increase the temperature, rate of reaction also increases. Catalyst. What is catalyst? I have written the definition. It is a chemical compound which alters the rate of reaction without taking part chemically or physically. Okay? Now what happens? Catalyst you add, it increases the rate of reaction. This is a new compound which you add, but which does not take part chemically or physically, means it will not create a compound. It will only alter the rate of reaction. For example, potassium chloride gives potassium chloride plus oxygen. Now in order to make this reaction faster, this reaction will occur, but if you want to increase the rate of reaction, by changing the temperature or concentration, this will not work. So sometimes when you want to increase the rate of reaction, you add a catalyst, and over here if you add manganese dioxide, the rate of reaction becomes faster. So these are the 5 factors on which rate of reaction depends. So now I have taught you various types of chemical reaction and factors affecting rate of reaction. Now very important question which can come from this topic is difference between combination reaction and decomposition reaction, or difference between displacement reaction or double displacement reaction, or difference between endothermic reaction and exothermic reaction. These 3 differences you need to know, where I will give you a word copy. I will forward a PDF format of this, which will be given into the group for your reference. But where any difference you want to write, you should write the first point, what is a combination reaction, the denotation part of it, and the example part of it. 3 points are covered, and to get 2 marks you need to write 4 points. So 3 points I have written. What is a combination reaction? Combination reaction is a reaction in which 2 reactant gives 1 product. What is a decomposition reaction? It is a reaction in which 1 reactant decomposes to gives 2 products. This is the first point. Then second point, you write this denotation, A plus B gives C, and second point in decomposition reaction you write AB gives A plus B, and third point you write the example of this chemical reaction, where H2 gives H2 plus O2 gives 2H2O, and calcium carbonate on heating is calcium oxide plus carbon dioxide. 3 points are covered. So in this very board, you have got the 3 points of differentiate between combination reaction and decomposition reaction. Same way, if difference between displacement and double displacement is asked, same way you can write the definition, the denotation part of it, and an example part of it. 3 points are covered. In the same way, endothermic reaction and exothermic reaction, you write what is exothermic, what is endothermic, okay, example of it, and an example in the form of chemical reaction. Then factors affecting rate of reaction are given. There are 5 factors: nature of reactant, size of particles of reactant, concentration of reactant, temperature, and catalyst. I also told you the definition of catalyst. It is a chemical compound which alters the rate of reaction without taking part chemically or physically. Jazakumullahu khair. Now the next type of reaction is oxidation reaction, reduction reaction, and redox reaction. These are the 3 types of reaction which were left. Previously we have studied about combination reaction, decomposition reaction, the third was displacement reaction, the fourth was double displacement, the fifth was endothermic, the sixth was exothermic. Now we are coming to oxidation reaction. The very word, from the word we can know what is oxidation reaction. Oxidation reaction is addition of oxygen or removal of hydrogen. Whenever you add oxygen or remove hydrogen from the compound, add oxygen on the reactant side or remove hydrogen from the reactant side, this reaction is known as oxidation reaction. Example over here, magnesium combines with oxygen to give magnesium oxide. The reaction is balanced. Over here, this is ethane. This is ethane. Ethane gives eth plus hydrogen. So here there is a removal of oxygen, hydrogen, and here there is an addition of oxygen. So in both the cases, wherever there is addition of oxygen or removal of hydrogen, that reaction is oxidation reaction. Same way, reduction reaction, it is addition of hydrogen. In contrast, wherever there is addition of oxygen, it is oxidation. Wherever there is addition of hydrogen, it is reduction. For example, hydrogen combines with chlorine to give hydrogen fluoride. Here it is addition of hydrogen to chlorine. So this is a reduction reaction. The next type is redox reaction. This redox comes from the word, you can see redox comes from the word Re means reduction, and Red means reduction, and OX is oxidation. So a reaction in which oxidation and reduction takes place simultaneously, that reaction is known as redox reaction. Redox reaction में क्या होता है? Reduction and oxidation takes place simultaneously. For example, you have copper oxide plus hydrogen. So over here gives copper plus water. Now over here see this over here, this is hydrogen is getting hydrogen, oxygen is getting added to hydrogen to form water. So this is H2 becomes H2O. This is oxidation. And over here copper oxide becomes copper. Oxygen is removed. Oxygen is removed. So this is reduction. So reduction is addition of hydrogen or removal of oxygen. What is oxidation? Oxidation is addition of oxygen and removal. मतलब plus of oxygen and minus of hydrogen, and reduction is plus of hydrogen and minus of oxygen. Okay, this is exactly oxidation and reduction is exactly opposite, and combination of oxidation and reduction is redox. So this example you see copper oxide minus of oxygen getting copper, so this is reduction. Hydrogen plus of oxygen, so this is oxidation. In this reaction oxidation and reduction is taking place simultaneously, so it is a redox reaction. Now there are two terminologies which are there in this chapter in the last. One is corrosion and the second is rancidity. Corrosion is what? It is formation of an oxide layer on iron which leads to deterioration of iron. For example, if you came during monsoons, you see the grills which are there outside the window. You see a brown color compound which is accumulated on the grill. So that brown color compound is your rust, or it is the corroded grill. Now what happens? These are the chemical steps which you cannot see. But rusting of iron or corrosion is also a chemical reaction. In this, there are three main steps. Step 1 is iron oxidizes to form iron ion. You can see the reaction Fe solid, which is the iron grill. It converts to Fe2 plus ion plus 2 electron because of the moisture. Oxygen is reduced to form water. This is the reaction for it. Oxygen gas, it combines with H plus ions which are there in the moisture, plus the electrons which are liberated from the reduction or the ionization of this iron. It combines to form water. Now this water combines with the ferric or iron ion to form a hydrated oxide layer, which is the rust. This Fe2O3 dot H2O, which is a solid compound which forms on the grill, black color grill, is the rust plus H plus ions. Okay, now this is corrosion. What is rancidity? Rancidity is also also a phenomenon which is noticed in the leftover oil of previous day for cooking. A foul smell is developed in the leftover oil or leftover food, and that foul smell or that phenomenon is known as rancidity. How it is produced? This leftover food or oil or ghee undergoes oxidation and becomes rancid. This, when oxidation happens, because of this chemical reaction, there is some chemical change, and that chemical change leads to a formation of foul smell, and that foul smell is also, the phenomenon of foul smell is known as rancidity. To prevent this rancidity or oxidation is prevented by putting this leftover oil, ghee or food in an airtight container. This is all there in this chapter. Coming again, oxidation is addition of oxygen or removal of hydrogen. Reduction is addition of hydrogen and removal of oxygen. It is exactly opposite of the oxidation. Redox, it is a combination reaction where oxidation takes place and reduction takes place. Minus of oxygen, copper oxide, oxide going, so reduction. Hydrogen forming water, oxygen adding, so oxidation. Corrosion, it is a formation of oxide layer on iron which leads to deterioration of iron. Okay, there are three steps which are chemical steps which are involved, which are followed by chemical reactions. The 3 steps are written over here. You need to you need to mesmerize. You need to recall all these 3 steps while writing the answer. And rancidity is phenomenon of developing foul smell on the leftover oil or ghee or food of the previous day. And rancidity, if you want to prevent rancidity, you need to keep that oil, ghee or food in an airtight